Okay, we're going to look at another section on geometry. And we will focus this on similar and congruent triangles and shapes. One theorem is that the sum of the angles of any triangle is 180. We will be using that in some of our diagrams. Doesn't matter how big or how small the triangle. Doesn't matter the shape of the triangle. If you add up the angles, you get 180. If you add up these angles, you get 180. Okay, similar triangles. Triangles are similar if they have the same shape, but the sizes are proportional. So think blueprints, or zooming in or zooming out. One triangle is bigger than the other, but they're in proportion, which we studied in an earlier lesson. The angles of similar triangles are equal, but their sides are not. Their sides are in proportion. So in the following example, triangle ABC is similar to triangle DEF, such that angle A equals angle D, angle B equals angle E, and angle C equals angle F. It's written that way on purpose. If you are told that triangle ABC excuse me, is similar to triangle DEF, that means just by the order that it's written, A and D are equal, B and E are equal, and C and F are equal. That also tells me that AB is in proportion to DE. Again, order AB, DE. BC is in proportion to, let me do a different color. BC is in proportion to EF. And then the last one is AC is in proportion to AC DF. And in this case, I have numbers. So my side AB and my side DE, because they're, oh, sorry, I didn't mean to say is in proportion. Let me erase this. Is AB corresponds, what color? Corresponds to. Okay, so AB over DE, because they correspond to each other. AB is 12, DE is 18. If I reduce that, I get 2/3. Same thing for AC over DF. And then BC over EF. BC is 10, EF is 15. That also reduces to 2/3. Okay. So this fraction, this ratio, is the same for every set of corresponding sides. I don't know why it's not. There we go. Highlight 2/3, 2/3. Okay, so it might not always be 2/3, but whatever it is, it has to be the same ratio for the corresponding sides. Whoops, too far. Okay, so let's practice identifying corresponding parts of similar triangles. So given that triangle ABC is similar to triangle DMF, angle A equals angle D. Angle B equals angle M. Angle C equals angle F. Now let's look at the sides. Side AB corresponds to side DM. BC corresponds to side MF. And AC corresponds to side DF. Given the following triangles, identify the congruent, the equal angles, and the corresponding sides. So I've got GHI and MNO. Now you don't have this information, but you do have some information. Angle, that's my symbol for angle. Angle G equals angle O. Angle I equals angle N, which means angle H has to equal angle M. And we can figure out what that measure would be because of that 180 rule. If I take 68 and add it to 35, I get 103, and then subtract that from 180, that has to be my other angle. All right, so if G is equal to O, if I say triangle GHI is similar, that's a symbol for similar, to triangle, well, I have to line them up in order. G is equal to O, H is equal to M, and I is equal to N. So my corresponding sides, GH corresponds to OM. HI corresponds to MN. And GI corresponds to ON. Okay, let's go to our next page. From the same set of triangles, given that GI equals 6, and HI equals 9, and MN is 21, find ON. I wish these were on the same page. Okay, so let's do this in, I'll do this in black. Come on. All right, so GI is 6. I'm looking for ON. HI is 9, and MN is 21. HI is 9, MN is 21. Okay, I'm going to do this over here. My whiteboard is being temperamental. Okay, so HI corresponds to MN. So HI is 6 over MN, I don't know, equals. Now, I started with the smaller triangle or the left triangle. So I did HI over MN. Now I have to go back to the first triangle, and the other side I know is come on, slide over. GI is 6. Okay, my technology is just not working. Okay, so HI is 9. Okay, so I've got 9 over X equals 6 over GI responds to ON. Okay, so I can see now my proportion and my triangles. HI corresponds to MN, so 9 over 21. Then I go back to my smaller triangle, and I've got 6, which is GI, corresponds to ON, and now I cross multiply. 9 times X equals 6 times 21, and then divide by 9. X equals 14. Okay, so knowing proportions, how to solve proportions that we did in an earlier lesson will help us solve our similar triangles. Okay. There are 3 main rules or theorems that are used to prove that triangles are similar. Angle, angle, angle. If all 3 angles of one triangle are respectively equal to all 3 angles of the other triangle, then the triangles are similar. Another theorem, side, side, side. If all 3 sides of one triangle are respectively in proportion to all 3 sides of the other triangle. And then the last one, side, angle, side. One angle of one triangle is equal to an angle of the other triangle, and the sides that make up that angle from the first triangle are respectively in proportion to the sides that make up the angle from the other triangle. Okay. And if you look in your book on page 385, that gives you examples of what I'm talking about. I am going to stop this recording here so that I can close my whiteboard and reopen it so that hopefully it will work better on the rest of this lesson.